Hey everybody, welcome to Eureka Math / Engage New York Math, Module 6, Lesson 13, describing variability using the interquartile range. And we can also call that the looks like a G, IQR, the interquartile range. As we look into the IQR, what this does is it gives us a really good idea of kind of what the data looks like when it was collected and takes into account some of those numbers that may be outside your normal range. So we're going to look at an example here. We've got a set of numbers, and we're going to say that this is a set of data, and we can say that this is how many pencils each student has in their cubby at any one time, or in their desk. It doesn't really matter, right? The data is ordered in order, obviously, from lowest to greatest, least to greatest, so it's already in order. And there are 17 total numbers. Now, if you recall in the last video, we found the median of the lower half of the data and the upper half of the data. Essentially, that was setting us up for the IQR, which is the interquartile range, which is what we're going to look at today. So first things first, we're going to look at all the different parts of IQR. The data is in order. We need to have that happen. Let's find the minimum and the maximum. The minimum is 1. The max, or the maximum, is 17. Okay, so now we're going to find the median. So if there's 17 pieces of data, that would mean there are going to be 8 on each side of the median, right? 8 and 8 is 16, so the 17th would be in the middle. So we've got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and then our median would be 10. This is what we essentially found in our last lesson. Now, we're going to find there's a lower quartile and there's an upper quartile. Essentially, the lower quartile is taking the bottom half of the data, and the upper quartile is taking the top half of the data, and it's finding the median. So, for the lower half, we have 1, 1, 2, 2, 3, 3, and then we've got 2 numbers here, so we know that our quartile 1 is going to be equal to 5, because 5 is in between 4 and 6. Let's look at the other half. We have 1, 1, 2, 2, 3, 3, and then we have 2 pieces of data here. They're both 15, so there's nothing in between 15 and 15. So this is quartile 3, and that is equal to 15. So when we look at the minimum, we have quartile 1, which is 5, quartile 3, which is 15. The median is 10, and the maximum is 17. If we take quartile 3 and quartile 1 and we subtract 15 minus 5, we end up with the interquartile range, which equals 15 minus 5 equals 10. Now, in this case, it is the same as the median. That doesn't mean that it always will be. So by looking at this, we see that most of our data is going to be between 5 and 15. Our median is 10. Our interquartile range is 10. And so just by looking at this, you can see that the median is a pretty good indicator of exactly kind of what we're looking at here. So our median and our interquartile range being close, or being in this case the same, shows us that the median is a good indication of the middle number, and it's also a good indication of the data we're looking at. It's not too skewed one way or the other. Here's another example. This is the salary of an NBA basketball team, the salary in hundreds of thousands of dollars. And you can see by looking here, and they've already done the work for us. They found quartile 1, quartile 3. They don't have the quartile range on here, but we can see that as you look in between here, the median doesn't appear to be right in the middle, and it won't always be like in that first example. But what you can look at here is to see there is a pretty wide range of where you find most of your information, and the median may be a pretty accurate look at the data here, because most of our information is still going to be in between here, but they have one player who is making, looks like, about $28 million. Big time player, obviously, and a couple other players who are making big time money that skew the data. They moved over this quartile 3, right? So if it had been kind of right in between, like that last piece of information, the median was exactly in the middle of the two quartiles. Here, because we have this information over here, these data points over here, which are very, very much higher than the rest of the data, it moves our quartile 3 to the right, and it increases it, and it increases our range by looking at the quartile range. I know a lot of that's kind of abstract, but we're going to look at some examples in class and go over some more information here about when we would use this. So we'll talk more about this in class, and we'll see you very soon. Thanks.